We have already covered the basics of smart contracts. What are they? Characteristics, benefits, etc. Time to look deeper into their functioning and what are the pitfalls that developers and designers need to be aware of. But before we get into smart contracts guidelines, it would be good for you to revisit the guidelines for dApps, as smart contracts are a component of dApps only, although the most important one. Summarizing the guidelines. Design. The design of the smart contract should be discussed ahead of time prior to writing any line of code. Documentation and specifications should be detailed, comprehensive, at different levels and up to date. On-chain versus off-chain. What needs to be kept or computed off-chain and what needs to be kept or computed on-chain. It is advised to keep the on-chain layer small. Upgradability versus migration. Make a deliberate choice to support upgradability or not prior to writing any code. The decision will influence how you structure your code. In general, the recommendation is to favor contract migration over upgradability. Also, create a detailed documentation of migration or upgrade procedure before deployment of any contract. And some of the implementation guidelines are simplicity. This is easier said than done. Strive for simplicity and always use the simplest solution that fits the purpose. Keep the enhancement plan ready and ensure that the complexities, if any, are built in stages. Repeat that detailed, clear, and easy to understand documentation is the key. Function composition. Ensure that the architecture is easy to review. Login should be split into smaller functions as much as possible, meaning develop small functions with clear purpose. Inheritance. Keep inheritance manageable by minimizing the depth and width of the inheritance tree. Use it to divide the logic into smaller chunks. Events. Logging of events, though an overhead, is one of the most important aspects. Keep event log of as many operations as possible, especially the crucial ones. This helps in easy debugging. Avoid known pitfalls. Be aware of the most common security issues, like in case of Ethereum, be aware of the warning sections in the Solidity documentation. The warning sections will inform you about non-obvious behavior of the language. Dependencies. Use well-tested libraries. Importing code from well-tested libraries will reduce the likelihood that you write buggy code. Use a dependency manager and avoid copy-pasting code. If you rely on an external source, then you must keep it up to date with the original source. Testing and verification. This activity often takes somewhat backseat in the entire development cycle, though all of you know how important it is. An extensive test suite is crucial to build high-quality software. Deployment. Monitor your contracts, watch the logs, and be ready to react in case of contract or wallet compromise. Even if your contracts are free of bugs, an attacker may take control of the contract owner's keys, therefore have a response to incident plan. Add your contact info to blockchain security contacts. This list helps third parties contact you if a security flaw is discovered. Secure the wallets of privileged users. Follow best practices if you store keys in hardware wallets. With these guidelines followed diligently, one can be sure of developing a good, stable, and working smart contract. Please note that this is not the exhaustive list, but a generic list of some of the important guideline points. They will differ from case to case and, depending on specific domain and environment, may take different shape and form. For example, smart contract developed in permissionless protocol like Ethereum will be slightly different than the one developed in permission protocol like Hyperledger Sawtooth. Though Both might be developed in JavaScript. Before we get to how smart contract works, let us revisit what is the smart contract. A smart contract is an agreement between two people in the form of computer code. They run on the blockchain, so they are stored on a public database and cannot be changed, right? That is what we have covered in great detail in the session where we introduced smart contracts. We also learned that the transactions that happen in a smart contract are processed by the blockchain, which means they can be sent automatically without a third party and no need to rely on anyone. Also, the transactions only happen when the conditions in the agreement are met, meaning there is no third party, so there are no issues with trust. So how does a smart contract works? Let us understand this with the help of an example. In our example, let us say that Alice wants to buy Bob's house. This agreement is formed on Ethereum blockchain using a smart contract. This smart contract contains an agreement between Alice and Bob. In its most simple form, the agreement will look like this. When Bob pays Alice, say 500 ethers, then Bob will receive ownership of the house. Please note that we have used the currency as ether because the contract is on Ethereum. If the contract is on some other protocol that supports the smart contract development and deployment, then some other crypto might be used. Once this smart contract agreement has been put into place, it cannot be changed, meaning Alice can feel safe that she will receive the contracted price of 500 ethers and Bob can feel safe that he will get the ownership of the house once he pays 500 ether for the house. Without the use of a smart contract in this scenario, Alice and Bob would have to rely on many intermediaries or third-party companies and pay lots of fee. These third parties will include the bank, a lawyer, and a house broker at minimum. It's great, right? No more commissions and no more delays to wait for a lawyer and a broker to process the agreement. This is just one of many examples of how a smart contract can be used. Let us look